Thanks for the intro. Hello everyone, my name is Faisal Zaman. I'm from Computational Media Innovation Center at Victorious University of Wellington, New Zealand. Today I'll be presenting Vicarious, the system we have developed to manage multiple viewpoints in mixed reality collaboration. Immersive media like 360 video allows user to view in all directions, but due to the limited field of view of the head-mounted display, the amount of information can be shown is limited and sometimes overlooked. Also, most of the telecollaboration system you can see from other people point of view, so the obvious thing would be adding multiple viewpoint. But the problem is managing multiple viewpoint can be challenging because user need to decide which view to focus on. For example, if you watch the video for a single time, it's very hard to comprehend what's going on. So it potentially leads to overlook information or user action. One solution is to physically shift or toggle viewpoint, but that consumes time and also add a cognitive load of choosing the right perspective. But if we somehow highlight it or guide the user attention, and that could potentially help. Over the years, people have tried to incorporate multiple viewpoint. For example, Magic Book is one of the earliest work which shown how to seamlessly transfer user from reality to virtuality. Another line of research tried to incorporate visual communication cue to guide user attention. Similarly, system like Transceiver used view sharing to enable external user to explore the VR scene. Multiple perspectives are also explored in, for example, in Jack in Space, which allows user to transition between first person and third person view. The viewpoint sharing also explored in more than one-to-one user. For example, Lee evaluated view sharing in one-to-many collaborative environment, and they looked into 2D, 3D, and 360 mode. But we haven't seen much study in automatic or guided selection or transition between multiple viewpoints. And we think exploring mixed perspective approach where the expert can transition between different viewpoints depending on which is better fit for their task at any particular moment would potentially help the remote assistant and training scenario. That brings me to our contribution. We present Vicarious, a context where viewpoint selection method that simplifies and automates the selection of multiple viewpoints. We ran a user study to evaluate our viewpoint selection method, and our results showed the need for such system and provided some recommendation for future design implication. So our setup is built on top of asymmetric multi-user AR VR setup, which uses a 360 camera that live stream local user space to multiple remote users. The details about the system are available in the following paper, which will be presented next week in ISMAR. So I'm going to focus on the details about the added feature that we have used to develop Vicarious. So as I mentioned, we have, apart from the 360 video, we also capture the video feed from the local user AR HMD and the video feed of VR user HMD. That gives us access to all of the video feed and to see where each user is looking and help us to calculate the optimal viewpoint. So how we did it? First, from a list of viewpoints, we extract the saliency information and used it as an indication of where the area of interest are. We create a saliency map by combining 3 attention cues. It helps to identify visually prominent content, but it wasn't enough to determine the optimal viewpoint. So we also incorporated a set of predefined functionalities and features. All these features user can access through user interfaces. For example, for verbal cue, all user can use voice chat, and we identify the voice activity and calculate the intensity. For visual cues, we had a pointer and annotation and gesture that translated through avatar, so we keep track of the changes in these user activities on the scene. and assign a weight values. Here is an example of the skew that I just mentioned. Apart from the skews, we display user viewpoint as a peep window or picture in picture mode window. So we also added a few interaction to make it easier for user to navigate between viewpoints. So for example, we had a smooth follow option, which smoothly follow user head movement. We also had a pin to fixed location. In this mode, user can pick the viewpoint and place it anywhere they want. We also had a click to zoom, so if user want to select any particular viewpoint, they can click on it and it fills up their viewpoint. We also had a special indication which indicate where the viewpoints, which user this viewpoint coming from. So I ran a user study. We wanted to evaluate whether it's a useful feature for remote collaborator. So we asked two questions. The first question was about the sense of presence, and the second question was about the task performance. So we designed a 4x2 mixed factorial design. We had 27 participants. It was kind of uneven between condition. This was run indeed kind of during the tail end of the pandemic, so it was hard to get more participants. But almost all of the users never used this application before, and we asked them to participate in a collaborative Lego and domino building task. So we had two VR user placed in a room and one air user placed in a different room. So air user have access to the real physical model of the Legos and domino pieces, where the VR user has the virtual replica of the model that needs to be built. As I mentioned, we had 4 different conditions. No selection method is just a stripped down version of the Vicarious with all the view selection tools removed. And we had manual selection, which allows user to manually choose between multiple viewpoint. We also had guided selection, which is visually highlight the optimal viewpoint. And finally, we had an automatic selection, which automatically select the optimal viewpoint. Let's look into the results. First off, we compare various forms of presence that were being induced. For social presence, we did see an increase for users in GS condition. This means that people were indeed more engaged in the conversation, especially for co-presence, which is the sense that you were there with someone, was high in the GS condition comparing to other condition. We didn't really see any significant difference in the spatial presence of each of the condition, which is the sense that you were really there inside that shared environment. However, it is worth noting that we didn't have too many participants, but the participant found the highlighted feature in the GS condition or the guided condition was effective in understanding the instruction. We received comment indicating that they felt present in the room, and looking through the viewport made it easier to observe the user activities, such as the annotation. Now let's look at the task completion time. The first thing we notice immediately is that people in the guided condition where the optimal viewpoint was highlighted for them could complete the task significantly faster than in the other condition. There wasn't any significant difference between the other condition. This is probably not too surprising because they don't have to find the viewpoint by themselves or attempt to select the particular viewpoint. because the system highlights for them. We also see significant difference in the perceived workload in the guided condition. The TLS score was significantly lower in the guided condition than in the other condition. Our third hypothesis was the guided and the automatic selection will have a significantly higher usability than the rest. Here we see the SUS score for guided selection was above average, which is beyond the 68 mark. However, we didn't find any significant difference between condition, nor did we observe any interaction effect. I have also looked into simulator sickness score. We found working in the manual selection setup resulted in a slight increase in total score. However, no significant increase in the symptom was reported. Particularly, it's worth noting that the participant in the guided selection reported experiencing considerably less simulator sickness than other. Lastly, we asked people which condition they prefer for various form of presence, and there was a tendency to prefer our system because people felt more engaged while they are using the guided and automatic selection. This was especially noticeable in question 4, which inquired about understanding and communicating with the partner. Participant perceives the guided selection as the most effective for understanding and communicating with the partner. As for the question 5 regarding the task completion, participant found both guided selection and automatic condition to be most helpful. Finally, we wanted to explore more input modality. For example, we wanted to incorporate depth into the system. We also want to run more in-depth user study and optimize our view selection method for much better performance. So in conclusion, what we did here is we introduced a context-aware viewpoint selection method that automates the selection between multiple viewpoints. Our optimal viewpoint selection takes visual saliency, user actions, and the current context into account. We ran a user evaluation in 4 different conditions with 2 using our viewpoint selection method to find the optimal viewpoint. Our system was implemented on top of a asymmetric multi-user AR/VR setup. More details about the setup can be found in our upcoming paper, which will be presented next week in ISMAR. Keep an eye out if you are interested in finding out more details. We found having optimal viewpoint selection improved user task performance, also the task space understanding, and also reduce the cognitive load. Overall, the guided selection was the most preferred and performing well across multiple metrics. And finally, why work remotely when you can work vicariously? Thanks so much for your attention.